Hi there, it's been quite some time since I did a YouTube video, exactly about 30 days. It's been a month. There are two reasons why there was a lot of delay, because 2 weeks I was actually engaged in back-to-back corporate training programs, so it's like totally tied up. And the other 2 weeks, the last 2 weeks, I was actually ill. I was running with viral fever, just recovered a couple of days ago, just about 2 days ago. And then I realized, oh, it's been a long time since I did a video, so let's dive into it. So what will I talk about today? Well, I'll talk about how you can get to know about the laptop's power consumption on your system. That basically, if you're using a laptop, sometimes you want to know what's the kind of battery utilization that's going on in your laptop. Obviously, if you're using a graphical user interface environment like GNOME desktop and so on, you will actually find a battery status applet somewhere in the corner, the system tray, which tells you about the battery levels. But what is a wattage drain on the battery? That information is not generally displayed on that. You only take the battery levels, and maybe it'll tell you about how many more minutes or hours of battery state is spending. So today I will tell you how you can actually get those details about the battery utilization of your laptop in general, and general power consumption of your laptop, and also ways you can tune them for optimal performance and optimal battery utilization if you're running on battery, right? So let's dive into that. Well, first of all, if you see that there's a command available. It's available as a utility. You can install that tool. It's not installed by default in many distributions, but you can actually install using a package manager. I'm using Ubuntu in here, so you should be able to run this command sudo apt install PowerTOP. This is the tool I'm talking about. This PowerTOP is basically a top-like utility, but it focuses more on power consumption, right? So right now my laptop is now running on battery. I've just removed the power adapter from my laptop on which I'm doing the recording right now. So you can actually test this at this point. PowerTOP requires root privileges. So if you just run PowerTOP as a normal user, you might get this error. So you might want to run it through sudo. So you can just say sudo PowerTOP. And yeah, by the way, if you're using other distributions like Arch Linux, you can actually install PowerTOP by using the package manager called pacman. You can say pacman -S and PowerTOP. If you are using Fedora or Red Hat based distributions, then I guess you should be able to use dnf install PowerTOP. So PowerTOP is available in almost all the major distributions package repositories. It's a standard utility right now. When you actually run PowerTOP, and if your laptop is running on battery, you get this interesting statistics on top. You can see this battery push discharge rate of 37.6 watts of power, right, on my laptop. After some inherent delay, you will also get to know about the energy consumed in joules. It tells you about its 759 joules, and it also tells you an overall estimated remaining time that the battery can last on my laptop. And what's also very interesting is that it gives you some details about the utilization of various subsystems and processes on your running system right now. Some things are shown, like, you can see this. It says 18.2 milliseconds per second. That means in 1 second on average, 18.4 millisecond worth CPU has been utilized by this particular subsystem. It shows how many events. It looks like 573 times this particular subsystem has woken up and utilized CPU, and it's just categorized under timer. So when you see timer, it's actually a kernel subsystem. The kernel has interrupt handlers, timers. Kernel has its own threads of execution, like we call them as K workers. So all these are categorized separately, right? So these are all kernel timers, which actually have taken up some amount of CPU usage. You can also see K worker over here. You can see K work. It's taken about 281.2 milliseconds per every second on average. You can see another K work which is actually taken up. You can see this. It's an Intel atomic commit work. It's taken about 694.5 milliseconds. There are other things which show up as process, which are generally user space processes. All of these are user space processes, and their CPU utilization is also shown here, and how often they have been woken up, how many events they've handled in a second. So those details are covered. And yes, you can scroll down. It gives you the complete details about all the processes running on your system, plus various kernel subsystems which are also active, right? So details about their CPU utilization is shown in here. This is what you see in the overview statistics. You can actually use a tab key here to switch to other tabs. For example, the next tab that you see here, it shows up as idle stats here, right? The idle stats under this header, which you can see here, it tells you about the overall idle statistics of each CPU. I'm running on a system that's got about 12 CPUs. Technically, it's a 6 core, and each core has got 2 hyperthreads. This is a Core i7 on the older models. So yeah, this is how it is. So it tells you about each CPU number: CPU 0, CPU 3, CPU 6. So each CPU, what is the utilization of the CPU, how much of time have been utilized from them. It tells you about those details completely based on how many CPUs you have. It also tells you about GPU utilization so far. Looks like it's been powered on. It's not been idle for idle state has been like almost 0.0. I think utilization is 100%, which you see here, right? So these are details that you find here. If you press the tab key again, it goes to the next section called frequency statistics, where it tells you the average CPU frequency for each CPU detected on my system. As I told you, there are 12 cores on my systems. It starts from CPU 0 to CPU 11. So each CPU, it tells you what frequency it's running on. Looks like the CPU is not being utilized to the brim. So if I actually run some compute intensive kind of code in here, the CPU frequency might go a little higher. By the way, I should also tell you that my laptop is having the BIOS settings also kicking in. Is Intel architecture. So there are things that BIOS handles by default. Though I call it BIOS, is technically the Intel management engine. So that can actually kick in anytime, preempting the entire operating system and trying to throttle the CPU if the CPU usage goes beyond particular threshold. Basically, the CPU temperature goes beyond a particular threshold. It tries to throttle the CPU and keep it to optimal utilization for saving the battery and making sure the CPU does not get overheated. So all these things are kicking in. So therefore, you'll see that CPU is not being used to the extremities at this point when running on battery. You can also get device statistics in here. It tells you overall device utilization in terms of power. All the power utilization of the devices that are shown here. Sometimes you can see is more than 100%. Can happen. Can go slightly higher than that. It looks like it's just a ratio, right? So it tells you about overall power utilization of all these devices. Looks like it's mostly about how often they are being turned on, right? All these devices. And when you go to the next tab, which is very interesting, it tells you about tunables in here. And I've seen many laptops when I run this, by default, you'll see a lot of these sections are shown as bad. You can see a lot of them are shown as good here, right? Which also means that all of these are tuned for optimal power consumption. So all of these subsystems, the power management system has been optimally tuned in such a way that when these devices are not being used, it's going to be powered off, right? So it's optimal for power management as such. So that's what you see here. There are certain things which are set as bad here. For example, virtual memory write back timeout, and auto suspend for USB device gaming mouse, and auto suspend for USB device XPG gaming keyboard. I think I'm using an external keyboard and mouse connected to my laptop, so these are always being powered on. Well, you have an option to turn them to good by just going and pressing enter here. For example, if I just enter on that first section, that's VM write back timeout, you can see what happens. It actually shows what command it actually executed over here. It shows that the write back timeout is set to 1500 centiseconds. Maybe it was set to a lower value before. It increased the value this time, right? So that write operation is not too frequent, right? And you can also look at auto suspend for gaming mouse. When I press enter, it actually set echo auto to /sys bus USB devices power control. So the whole idea is that when you actually set all these options to good, the battery utilization will be more optimal, but there may be some latencies involved, especially looking at hard drives. If you're using electromechanical hard drives, which have all these motors to turn on the plater and things like that, if you power them off completely, when you try to access the hard drive after some delay, there'll be an inherent latency involved in powering up the hard drive, waiting for the motor to reach a concentrational speed and get access to data. So there'll be some latency involved. Even some of these devices like gaming mouse or keyboard, if they are powered off after a long sense of not. Right now this mouse is still powered on. I see the lights are on my mouse. There are some LEDs that's on, but if I keep this mouse unused maybe for a couple of seconds, maybe 30 seconds or 40 seconds, maybe they might get powered off. And once it's powered off and I try to move the mouse, there'll be some latency involved in powering up the mouse and then accessing the contents. So these are the latencies that can be added up here. So yes, if you're running on battery, I think it's a good thing because it's going to save battery power. So that way it is more efficient. So on the contrary, if you are looking for extreme performance, these things are generally set to not good, but bad, right? Anyways, so all of these are different sections that you see. The last section is wake up. You also have an option for wake on LAN and wake status for USB device. you have an option to either enable or disable them. If you disable them, it's going to be optimal in terms of battery utilization. But if you enable them, you can have all these features like wake on LAN and wake on USB. That means your system can go in a very completely, almost like a power off state, completely suspended. But the moment you get an incoming packet from the network, or if there's any activity on the USB device like keyboard or mouse, the system can wake up, right? Resume from power management mode, suspend mode. But all these actually takes up some amount of battery power for polling for all these activities. So that's why if you don't really need these features, you can turn them off and optimize for your battery utilization on your laptop. So this is a tool that gives you all these high-level details, right? You can use tab keys to navigate around, and you can press escape to come out of this tool. I press escape once. It's going to take some delay. There's a lot of delay actually. Yeah, I'm not sure why, because just trying to press escape. It's going to take some time. Okay. Okay. Yeah. It takes some time. It takes a couple of seconds to come out sometimes. I think it's because of the polling loop it's running on to get all these statistics. Yeah. By the way, this particular tool, PowerTOP, also has command line switches where you don't need a textual user interface and you want to just quickly generate a report and all that. You could use this feature. Some useful features I can think of is the first one, minus auto tune. If all you want to tune the settings of all the hardware devices to be optimal in terms of battery utilization, you can actually say sudo PowerTOP minus auto tune. It's going to make all the settings as good, right? By writing to the appropriate members. It will just optimize it now, optimize for battery, right? If you want to, let's say, get the statistical information rather than showing a textual user interface, you want to get it on a HTML report or a CSV report, you could actually run PowerTOP and you can say -C if you want to generate a CSV style file, which you can open in a spreadsheet utility. Any kind of spreadsheet utility will do. The CSV format file after all. It's going to take about 20 seconds duration. It's going to take a measurement of 20 seconds duration and give you statistics from that. So there'll be some delay because of this. Okay, I think there's ways to even reduce that timing. Yeah, please generate this file. So if you just look up PowerTOP.csv, you can see CSV format details right in here. So all the details that's actually be shown in the textual user interface in different tabs are now collected in a CSV format report, right? If you don't want a CSV file, but you want an HTML which you can open in a web browser and view it, you can use PowerTOP minus, I think I'll just show you that. -H will show you. Its option is -R. -R will generate a HTML report. So you can also specify the sample seconds to be shorter. If you think 20 seconds is too long, you can actually reduce this, right? So you can say -sample and -time can be reduced. I can actually say -R, -S. I'm going to take a sample rate of 1 second and the time interval of, let's say, 5 seconds. I think it's -S1. Okay, looks like I think the combination switches, right, might cause a problem sometimes. Let's try this. Oh, -S doesn't work for some strange reason. Let's try -sample. Or -time is equal to seconds. Sometimes the long options are better. You can see it's taking measurement of only 5 seconds now, rather than 20 seconds, which was the default. It generated a PowerTOP.html, so you can use any web browser. I'm going to use a command line web browser to view it. You can also use a graphical web browser. I'm just lazy now to open up a GUI web browser. You can just say use tools like Lynx, eLinks, or LYNX. All of these are command line web browsers, which you can install on your terminal. So I'm using eLinks for this. You get the same details in HTML format. Everything that is seen on different tabs are shown up in one big HTML report, right? So useful for report generation and so on. Now, if you're not interested in using this tool, let's say you're not interested in using this particular tool called PowerTOP, but you want to find out the battery utilization on your laptop without using any specific tool, you can find that out on Linux by looking up the Sysfs file system. Actually, PowerTOP reads Sysfs file system to get all these details. Sysfs is a pseudo file system just like procfs. So we just look up ls/sys/class/power supply. If all you are on a laptop, if you use a laptop, you will very likely see a symbolic link called bat0. There are some laptops I heard about which might contain multiple battery sections, bat0, bat1, but most laptops, most commodity laptops just have one single battery. You'll see bat0 here. So if you just go look up bat0, you'll find a lot of details in here, You'll get to know about the manufacturer, the model name, the serial number, all those details are there, technology. For example, you want to know what's the battery technology that's being used, just type technology in here. It'll tell you it's a lithium polymer battery. What's also interesting is that you can actually find out the overall wattage of the battery. What is the capacity of the battery? To find out the capacity of the battery, you can actually use this, get this file, energy, full design. This is shown in microwatts. So actually that's why there's so many zeros. So we just cut off about 6 zeros in here. You'll see it is 90 watts, right? So I have a laptop that's got a 90 watt battery. But for now, we can find out what is the full charge energy, which is there. It shows you energy full is 86 watt. It's generally charged up to 86.68 watt. It's configured in the BIOS. You can change that in my laptop. You can also find out what is the energy right now, how much of wattage is available in the battery. You can find out by looking up energy now, which shows up. It looks like it's got about 70 watts worth juice right now. So it's got 70 watts. If you want to find out what's the power being drawn from the battery at this point, you can actually look up this particular file called power now. Currently, the first line that was shown when you run PowerTOP, where it showed 37 point odd watts, it got it from this particular file. Currently, this file is giving you details in microwatt precision. So yeah, if all you want to get in wattage, you can just divide by 1 million and you get this. So if you want to do it in shell, obviously one of the ways you can do that. If you want to get it at just integer precision, you can do it in bash shell. It's very straightforward. You could simply say echo dollar double parenthesis, and you can just say dollar parenthesis less than /sys/class/power supply. I hope I've spelled it correctly. Auto completion didn't work. Okay, anyways, sometimes it doesn't if you have complex flow like this. Anyways, bat0/power now. Divide by 1 followed by 1, 2, 3, 4, 5, 6. 1 million. 36 watts. But sometimes you want to have floating point precision. Unfortunately, with bash shell, you cannot get this feature. Bash arithmetic expansion only supports integral feature right now. If you want to have floating point by default, you can try the same command in KSH, mostly KSH 93 and above. It'll provide floating point precision. So I can just show it you with the KSH shell. Same command. Oh, it shows 36. Maybe I had to make one of the members float and might come up with floating. I'm not sure why this happens. I think some issue with my key binding. I think the key binding support is not turned on correctly. So, oh, it's in VI mode. Sorry. I think I should go to the end. In one of my earlier sessions, I think I switched the mode to VI edit mode. So that's a problem right now. Okay. Anyways, let me just go back here. Go to insert mode by pressing I and put a .0 and see. Yep. You can see it actually shows the floating point out here. This is with KSH. It doesn't work with bash, right? So if you try with bash, it'll tell you it'll only support integral division. I'm just going to exit KSH in bash shell right now. Try the same thing with bash. It shows this error. If you're on bash shell and you want to get floating point precision, you're not out of luck. Very likely in all Linux, you'll have a tool called BC installed, basic calculator, right? you can actually use this. Instead of doing arithmetic expansion in bash shell, you could actually try echo dollar less than this particular number. I guess if you just run this, it'll just echo this way, right? What you need to do is we need to actually add another command called scale is equal to, maybe I want to have floating point precision up to 2 decimal points, so it says scale is equal to 2 semicolon, and this particular expression is what you see. I want to send this expression to BC. To do that, I can say pipe BC. It shows that the power drawn right now is 35.5 watts. One of the things I also observed on my laptop, this specific my laptop, I believe, I try to put the CPU to full utilization. Part of that, the power drawn did not go much higher, right? If it's on battery. So it actually looks like the BIOS is throttling the power utilization, making sure it doesn't go beyond 35 watts. So I think that's the limit for the consumption, power consumption over here. Right now 35 is the maximum limit it looks like, because OBS Studio is running on this laptop right now recording, so it's obviously CPU intensive. The CPU is being throttled a bit, right? It does not go to the full utilization. It doesn't say okay, consume 70 watts and so on. It doesn't go to that very high wattage rate, right? So there's some kind of throttling implemented by the BIOS. So you can see that. I can actually demonstrate that by going to another terminal, bring up another terminal. I'll just cp/dev as urandom. And this is a very CPU intensive code, right? This command will make the CPU utilization 100%. So I'm going to run this command like say 12 times. 1 2 3 4 5 6 7 8 9 10 11 12 CPUs 12 times. So all the CPUs are going to be busy. If you actually run tools like htop right now, I'm going to show you the CPU utilization is like, you can see all reds, 100%, right? It looks like it's all busy in the kernel space. And you can see all the CPU utilization is almost showing almost to the brim, right? In spite of that, if you actually go and look up the power drawn in here, it's actually dropped to 30 watts. It's a little surprising. This is a feature that many laptops might be having to make sure that your battery doesn't drain out very quickly, aggressively, just because your CPU is running in full throttle. Actually, the CPU would have been throttled running low frequency at this point. So if for all you look it up right now, I'll just say, I'll just run sudo PowerTOP. And look at the CPU frequency statistics. You'll see it's actually not gone to the extremities. And you can see that utilization of this quite high, right? It's quite high. But still the discharge rate is at 30 watts. Still it's trying to keep my laptop on for like 2 hours, 11 minutes by throttling the overall CPU utilization while on the battery. And actually, if you just go and check it up in the frequency stats, you can see that it is not increased beyond 1 gigahertz. Fully throttled, the CPU is throttled, right? The CPU is actually capable of running at 4 gigahertz on my laptop. The 4 gigahertz CPU. In turbo mode, it goes to 4 gigahertz. On average, it's 3.2 gigahertz, right? At least it has got that kind of a performance, but it doesn't do that. But having said that, if I just connect the power adapter, things change a bit. So I'm just going to try that out. I'll just hang in there. I'll just try to connect the power adapter to my laptop. Yes, I have connected the power adapter, and you can see immediately the CPU utilization is doubled up. It's gone to 1.5 gigahertz at this point, and the power drawn would also be a little higher. You can see that I can actually hear the fan running. It's not going to be captured in the microphone because of noise suppression plugin and things like that. But yes, the fan's running on my laptop. Actually, when I connect the power adapter, it's the PowerTOP tool is not going to show you the power drawn, right? It's because I guess many laptops will not show you battery statistics accurately when it's being charged, when it's connected on the charger. But on my Lenovo laptop, manually, if you go and check it up, you can see the power drawn will be slightly higher. Yeah, when I leave this and if I just look it up in here, see the power now is actually gone to 51 watts. While on battery, it never went beyond 35 watts. It was like throttled at 35 watts, 35 to 37 watts, right? But because I've connected to the charger, it's actually able to draw more power at this point. It's not drawing from the battery. It's a little misleading, I believe. So it looks like it's coming directly from the charger. So it could be the case. Many laptops, this power now will not even show up anything, right? That's the reason why tools like PowerTOP refuses to read these details when the battery is charging, right? You can actually find out what the status of the battery by also looking up this particular file. In batch 0, there's a file called status. It tells you whether it's charging, discharging, right? And you can also find out the capacity level. This is the capacity that you actually see in a battery status update. It shows the battery is right now at 77% of charge, right? If you keep this charging, it'll go from 77 to 78, 79. It goes on all the way till 90-95% on my laptop. And you can also find out the capacity level, indicating what's the state of the battery, whether the battery is normal or the battery level is too low. The battery level is low, obviously they'll have other triggers clicked in, like the alarms to click in to make sure that your system can power off automatically in a safe way, right? So all these things will depend on this capacity level. So actually, if you look up this particular folder /sys class power supply batch 0, you'll find a lot of details. Depending on what kind of laptop you use and what kind of battery capabilities are on your laptop, you'll find a lot of details in here, so which could be very useful. You have the capacity level. There's also something called charge behavior, which you can actually write to. You can actually write to this file, indicating whether the battery should go into full discharge mode, whether the charging should be automatic and all that. So you can actually look it up. This file right now shows you these details. Right now the charging is automatic. Decides when to charge, when not to charge automatically. But you can actually select inhibit charge. If I say echo inhibit, this requires you to run as root user. Normal user, I don't think I can run this. I'm going to use sudo su minus and say echo inhibit charge greater than /sys class power supply batch 0 / charge behavior. You can completely change the charging behavior by writing to this file. Now look up this entry now. Sorry, I need to get this file. I use the Alt-D command to delete words, just in case you know what I'm doing, right? Right now I'm gonna do a cat on this particular file. Okay, I think I deleted /sys there. Sorry, I deleted too much. Yeah, right now you can see it is inhibiting charging. Start charging the battery. You can also enable force discharge. It'll force the battery to discharge very rapidly at this when you select this. So all these are mostly for testing purposes. I think you should leave it to auto for normal course of usage, right? You also have options to write to charge start threshold, charge stop threshold. You can say when to start charging the battery. When the battery status goes below a particular threshold, start charging it, and you can ask it to stop charging the battery once it hits maybe 95% usage and so on. So you can actually control the battery charging behavior by writing to these files. So all of these are interesting tunable parameters that you can use, which you can tune how well you can optimally charge and discharge your battery. There's a lot of theory about not keeping your battery always charged. They tell you to discharge the battery once in a while. Make sure that the full battery discharge cycle happens all the way to, let's say, 20%, then you start charging the battery again. So if you want to keep that kind of a cycle, I think you can tune these parameters on Linux. There are specific tools you might find on Windows that you need to install on Linux. This comes out of the box. All these are just files which are exposed by the battery driver that's available on Linux kernel, right? So I'm just going to select auto at this time. The charge behavior. Anyway, so I'll just give you an example of how you can actually get a lot of details about power utilization, controlling the battery status, and so on. To summarize, if you want to find out what is the power utilization of the battery on your laptop, just remember this one single file. Path is obviously, you want to say cat /sys/class /power supply /batch 0 /power now. This will tell you the current power utilization from the battery, right? If it's on charge, this might be misleading. I don't think this is actually discharging the battery at this rate at this point. It's coming from the charger, so obviously, right? So If it's running on battery, this will be the more accurate picture, right? When it was running on battery, you would have seen numbers like 3.6 and 3.7 and 3.2 kind of numbers, like 30 watts to 37 watts on my laptop. So this is what you should look at, right? And once you know how the rate at which your battery is draining, you can optimize your processes and making sure that not too many processes running, and you can throttle them. You can also make sure that you can auto tune all the devices to be in suspend mode when not being utilized. So this way you can actually optimally utilize the battery on your laptop, right? Hope you found this details useful on this video. If you do have any queries related to this, you can always shoot a comment on this video, so I will try to answer them. Thank you very much. So hope to meet you in another video, right? Thank you very much.